Hello. Quietly move the microphone around. How's it going? Oh, make sure I've got everything set up here. Okay. Welcome to another question show. Your questions, my answers, all that. So go ahead, if you haven't already, start putting your questions in to the chat, and the moderators will find those questions, identify them, put them into the database that I will then use to answer questions. So if you're wondering sort of like what is the process, if you've never been through this before, we will spend the next hour recording the show that will eventually become the QA. And then we will, I'll wrap up the recording, and then we will stick around and we will do overtime where we will answer more of your questions until I run out of energy. I've just eaten dinner, so I feel good. I think my wife's going to have a nap. So, I don't feel any pressure. So I like our odds. Okay. So if I don't answer your question, there's a couple of reasons. One is I try to give emphasis to the people who've never had a question answered before. So, when you ask your question, we remember how many times you've had your questions in one of our published shows. And so if you've had that question before, or if you had like a bunch, I'll try to put emphasis on the people who've never had a question answered before. But typically I'll then sort of catch everything up at the end during the overtime. So if you're still around, then we'll do that then. I might not know the answer. Like, I'm just a journalist. I'm not a scientist. So I am a very fancy chat GPT for space news in human form. And so I'm able to synthesize the discoveries that have been made by other people, but I am, ill-equipped to provide you any kind of cogent analysis of the state of various theories. I have no opinions. I have opinions, obviously, but don't ask me what I think about some one kind of cosmology over another one. I can just tell you what other people think. And if the question requires a bunch of math, so I'll use my judgment. But if I'm gonna have to spend 5 minutes going through Wolfram Alpha, finding answers, that's kind of boring. So we want to sort of keep it snappy, So, all right. I'm going to start my recordings, and then we will get into this week's episode. Hope you all had a entertaining scrub watch this morning with Starship. What? It didn't launch on the first time? What? Yeah. Welcome to watching rocket launches. This is how they roll. Okay. Let's make sure. All right, I'll start my recordings. Actually, the timing is really good because hopefully we'll be able to record our Space Bites on Thursday, and then they'll have just launched, and then we'll be able to record and tell what happened. But I'm guessing even on Thursday, it's just going to scrub again. Like the first time a new rocket launches, remember what happened with SLS? This is how rockets work. Is they are delayed. Shocked. Well, not that shocked. So, I'm guessing 3 weeks we will see the launch of Starship. That is my guess. Which, if you're completely shocked at that prediction, then you probably haven't been through a lot of brand new rocket systems. It's been 10 years since Falcon 9 started launching. All right, let's get going. All right. Hi, everyone. Welcome to the question show. Your questions, my answers. Now, as always, wherever you are across my channel, if a question pops into your brain, just write it down. I will gather them up and I will answer them here. Now, we also record the show live every Monday at 5 p.m. Pacific time. So This question show that you're watching is the result of a live show where people came and hung out and asked me a bunch of questions, and I answered a bunch of questions, and it was a good time, and you definitely want to be a part of that. So there should be a notification for the next time this is going to happen. Subscribe, click the notification bell, put a post-it note on your fridge, and that way you won't forget to come back here Monday at 5 p.m. Pacific time. All right, let's get into the questions. Matthew Serum. Why this is still boggling the mind is because you keep holding on to the Big Bang Theory, which is wrong. James Webb proved it. I don't know what happened, but in the last couple of days, one of our older videos got picked up by the algorithm, and now we're getting a lot of views on it. And all of the comments are some version of this comment, which is, you scientists, lol, Big Bang, haha, dummies, and then they'll make some kind of assertion. Usually, like, they have their own personal theory, and like in some cases, I'll get it, they'll want to send it to me in the form of a book or some kind of paper that they've already published. And like, I am not the person to send your theories to, because I am not capable of analyzing whether or not you're correct. I am not a scientist. I'm not a cosmologist. The people to talk to are the cosmologists. But my guess is you've tried that, and the cosmologists have ignored you or told you that they're not going to consider your theory. And the reason for that is because the way that scientists communicate with each other is via science journals. So they will do a piece of research working with the James Webb Space Telescope. They will publish that paper starting with a prepress like archive, but then they're really hoping to get their paper into the journal Nature, into the Journal of Astrophysics, all these different journals. And that is the process. That is the way that scientists talk to each other, is through journals. And so if you want to have your ideas taken seriously by the scientific community, you have to get your work published in a journal. And there are hurdles that people have to jump through to be able to get their work published in journals. And it's designed to, with peer review, having various hurdles that people will have to overcome to get to that point. And, like the reality is that this process has evolved over hundreds of years, where scientists needed some way to be able to filter what are the ideas that have the potential of being correct and which are the ones that don't have any kind of understanding or underpinning that sort of helps them understand whether or not they should spend their time, because scientists have a limited amount of time. They should be researching and they should be keeping up to date with the literature. And so this is the trap. And there's some great, I've done some great interviews. I think one of my favorite books out there is by someone named Geraint Lewis. And I did an interview with Geraint about this, and we just talk about, like, scientists, astronomers would deeply love to be proven wrong about the Big Bang cosmology. It's incomplete. They know it. There's something else there, and they don't know what that is yet. And they would dearly love somebody to bring them the correct answer. But there are a lot of established pieces of data, a lot of underpinning. There are many separate lines of evidence that support the current theory of the Big Bang. And any new theory has to both explain those current lines of evidence and make testable predictions that people then can go out and prove. And ideally, like, it explains some of the ongoing mysteries, like dark matter, dark energy, why there's more matter than antimatter in the universe, and so on. And it's a really difficult hurdle to overcome. And for some reason, like I'm not sure why, but people, when they want to take on the biggest theories, they want to take on Einstein and they want to take on the Big Bang. Um, but they don't want to pay their dues. They don't want to go to a university where the current theories are taught. Like in many cases, it's someone in a different field. Maybe they're an engineer, or maybe they work in electronics, or maybe they're a medical doctor, or maybe they're just a entrepreneur and they have ideas and they want somebody to listen to their ideas. And unfortunately, this is how the system works. So, like I said, James Webb did not prove that the Big Bang is incorrect. And what it found was that what it found is that there are galaxies that seem bigger and more mature than anyone ever anticipated when they took their theories about how quickly matter should come together, how quickly stars should form, how quickly black holes should form and accrete material around them, and how dark matter should be able to concentrate matter into smaller areas to form these galaxies. They took the best understanding, the best theories that they had at the time, and they ran models of what we should expect to see in the universe. And the structures that are being seen right now at the very limits, like just a few 100 million years after the Big Bang, are bigger in some cases than anyone had expected. And that's exciting because it gives you constraints. It gives you some ideas and says, okay, these methods of accumulating matter, of bringing galaxies together, of star formation are more likely than these other methods. But when you look at the foundations of the Big Bang, like when we look in all directions, we see galaxies moving away from us. When we look out to the farthest that we can possibly see, we see the cosmic microwave background radiation, which perfectly matches the time when the universe became transparent and was able to let out radiation into the universe. When we measure the amounts of hydrogen to helium in the universe, we find that the ratios exactly match a universe where it was so dense at one point that the entire universe was acting like a star for like 10 minutes. And all of this hydrogen was being fused into helium, but then it expanded to a point that this process stopped perfectly. And so any new theory that comes up has to go, okay, here's why all of those galaxies are moving away from us. Here's why the cosmic microwave background radiation is in this exact temperature that we see. And here's why we see these abundances of hydrogen to helium in the universe. And that's just like the three major pieces of evidence. There are like another dozen minor, other lines, independent lines of innovation. There are like another dozen independent lines of evidence that confirm the Big Bang theory. And so when someone says James Webb has what is wrong with my speaking today? All right. And so when someone says that the James Webb Space Telescope has disproved the Big Bang, what I hear is I have a theory for how the universe works, and it is going to overturn Einstein. It's going to overturn the Big Bang. I like it better, but I haven't done the work to be able to replicate the results of the existing astronomers. I haven't taken the time to get a formal education in cosmology and astrophysics to be able to publish papers in journals in a way that astronomers are going to be able to take this seriously. I want to shortcut the process and get publicity, and I want to try and convince news journalists to publish my theory. And I guess some do. I mean, when you look at what happened with when James Webb first saw these big galaxies, then you did see a lot of stories out there. But I'm not going to do it. I'm going to wait until I see a lot of evidence from the scientific community, consensus, and then I'm going to report on it. And that's how I've got to work. And so, like, I understand that it's frustrating for people who've come up with an idea, but otherwise we would all run out of time dealing with all of this stuff. Like, I probably get 5 alternative theories about cosmology sent to me every week. Maybe 10, probably 10. I'd say I get 10 alternative theories of cosmology sent to me every week. And I know that the scientists out there get an order of magnitude more than that. Dozens a week. They don't have time. So they have to figure out a way to shorten that process. And that's what they do. So James Webb did not disprove that the Big Bang happened, but it is providing a lot of really interesting insights into the early evolution of the universe. All right. Okay. All right, I'm sure you've noticed the planetary name that appeared above my shoulder here, and that is a way for you to vote to tell us which of the questions this week you thought was the best. And the winner last week was for Peter D. Great about bringing samples back from Mars and whether or not it was risky. And a lot of people liked that question and answer, so congratulations, Peter. Congratulations, me. Thank you, everyone who voted. And please, you're going to see those names throughout the rest of the show. Go ahead, vote. Just put the name of the planet down in the comments down below, and we will gather all those up, and we will calculate the winner next week. All right, let's get back to the questions. Sean Gunn, what is the purpose if the rest of the planets in our solar system that has no life? Why are they there? Taking up space? Hello? Please answer. God. Apologies. A little, welcome to spring. So I guess the question that you're really asking is, like, if the rest of the solar system has no life in it, if it's just rocks, regolith, other minerals, various volatiles, water, nitrogen, oxygen, just molecules pulled together by gravity, what is their purpose? Should we feel any reason not to just use the solar system as another resource? And I have no problem with that. Like, if we want to go out and crush up asteroids and use them for our giant asteroid factories, that's fine with me. If we want to tear apart the moons of Saturn and turn them into water that we can use for our Titan swimming pools, fine. There's no life out there. But before we get to that process of extracting all those resources, we should just check. And we haven't really checked. Like, we have sent a couple of rovers, we have sent a couple of experiments that have provided inconclusive results to tell us whether or not there's life out there across the solar system. And the question of whether or not there is life in the solar system is really important, because if we find life on Mars, we'll want to know whether or not we are related to that life. Do we and that life have a common ancestor? Was there some panspermia where life was going back and forth between Earth and Mars, or maybe Venus? We don't know. But if the life on Mars is completely independent from the life on Earth, like, it's not even DNA, it has no common ancestor, it evolved completely separately, then that's exciting and also scary, because it means that life could form anywhere. in the Milky Way. And it makes it a little weirder that we don't see life anywhere when life formed on Earth and life formed on Mars and life formed under the waters on Europa and life formed on Pluto. And everywhere we look, we see life, and it's not related. And yet we don't see life at Alpha Centauri, or we don't see life at other places. It's a very, this is one of the sort of lead-in arguments into the Great Filter. So something wipes out life in our future, and that could include us. But no, if we don't find any life, then, I don't think we need to have any kind of like moral obligation to use the solar system as a place to extract resources and a place to dump our waste. Like, Earth is very special. Earth is the only place that we know of in the entire universe that has life on it, and we know that it's the only place in the universe that has panda bears and has octopuses and cedar trees and cyanobacteria and tardigrades. Like, there's all of these life forms that are here on Earth. And every day that goes by that we pollute the atmosphere, that we pollute the water, that we cut down the forests, we are decreasing the number of species on our planet so that we can have a better life. And the inevitable outcome of humanity's process, like, we are in the process of turning a natural habitat into an human-designed planet to some extent. And the species that exist here already will be the ones that we drive extinct. And so if we can go and get all of our heavy industry off Earth, if we can send our garbage into space and just let Earth be the place for life and let the rest of the solar system be the place for all the other stuff that we want to do, I'm perfectly fine with that. I mean, the only limit that I personally have is that I think there are some aesthetic reasons why we would want to keep some places in the solar system, like Valles Marineris on Mars, the largest, deepest chasm in the solar system, or some of the places on Titan, or some of the geysers on Europa. Like, there's a lot of places across the solar system that are pretty cool. And if, we could go a long way just crunching up asteroids, crunching up Kuiper Belt objects, crunching up comets, and leaving some of the more beautiful places in the solar system for us to be able to appreciate in the future. And so I think it would behoove us shortly to set up wilderness zones across the solar system that we can then leave untouched while we harvest the rest of the resources, which we will. It's inevitable. And I think for the life, if we do find the life, I got bad news for that life, which is that we're human beings and we're going to do what we do. And what we're going to do is we're going to take your places and take your spaces and probably make you extinct. But it would, that's just inevitable. And I'm not saying that's a good thing. I wish we wouldn't do that, but it's what we tend to do. But I would like to know, if we can, where that life came from. Try to understand it. Is it separate? Are we related? And are we anticipating that we're going to find life anywhere across the Milky Way? So, and if there is no life out there, I actually think it's our duty to spread life away from Earth, to go across the solar system, to even take life to other star systems, that life is better than non-life, that having life here on, having a universe with life in it is a more interesting place. And if there is no other life out there and we wipe out all life on Earth, it'll make the universe sadder for it not getting a chance to enjoy having life forms all the way across it. And it's in our hands to be able to do this. So what is the purpose of the solar system? Who knows? But we'll find out eventually. Except Europa, attempt no landing there. Listen, I'm not going to follow the rules of an Arthur C. Clarke book on how to explore the solar system. It's just science fiction. Aaron Calhoun, how massive does a star need to turn into a black hole after going supernova? So astronomers think that when the most massive stars die, they turn into various degenerate objects. So black holes, neutron stars. Actually, the most massive stars, when they go supernova, they just detonate entirely and disappear like a big puff of exploded star, and there's no remnant at all. But smaller than that, like less than, say, 50 times the mass of the sun, down to 8 times the mass of the sun, you're going to get a supernova. Smaller than that, actually. But anyway, and so the ending result is that if you have an object that has less than 1.4 times the mass of the sun, you get a white dwarf. If it's more than that, up to about 2.2 times the mass of the sun, you get a neutron star. And then beyond that, 2 plus, you get a black hole. But that is like the final result. Like that's the amount of material that's compressed into a small area that turns into a black hole. And so I think the question you're asking is like, how much star will give you that black hole? And it really just depends. Like it depends on how that star dies. How quickly does that star blast off its outer layers into space? How symmetrical is the explosion that happens when the material collapses inward? But it's roughly 8 to 10 times the mass of the sun at the bottom end. And so if you have less than 8 times the mass of the sun, you will most likely get a neutron star. And if you have more than that, you will most likely get a black hole. But you know, it's a sort of moving target as people are figuring out more and more about this. And then one other thing, we talked about this last week, is this idea of an unnova, that there are certain objects out there that instead of, you know, all the material collapsing inward and then you get the black hole and the material bounces, you actually get the material just coming together and then just turning into a black hole. And so it might be that actually smaller objects can turn into black holes as well, depending on how that material comes together. And that's still an unsolved mystery in astronomy. Delvling. What is your favorite sci-fi book which uses futuristic scientific ideas? Well, my favorite sci-fi book tends to be the sci-fi book that I'm reading right now. And that's like always the case. So when I was reading, uh, man, so like when I was reading Andy Weir's books, those were some of my favorite scientific ideas. When I was watching The Expanse or reading The Expanse, those are some of my favorite ideas. Right now, I'm reading Revelation Space series, although I just finished. And those are like my favorite ideas. That, you know, when I read science fiction, I will park my skepticism as I read the story because it's not doing me any favors because I know too much. And so when I see something that is unrealistic, I I just let it go. Like I'm just like, that's cool. Sure, why not? Um, I'm not here to critique this. I'm just here to enjoy the story. Um, but the ones that really resonate are the ones where someone has really thought through the implications of this and has proposed ideas that make a ton of sense. And so, for example, as I'm reading the Revelation Space series by Alistair Reynolds is a physicist. He has his degree in physics. And so the ideas that he proposes in his stories hold to the laws of physics as we understand them, and yet are extreme to the max. And I really enjoy that because I will hear this idea for a starship drive or a spacesuit that can protect the wearer, or an explanation for some kind of alien species, and you're like, oh, that all works. That's really cool. So I can't give you any specific answer. My favorite book is the one I'm reading right now. But at the same time, like, science fiction isn't about the future. Science fiction is about now. And you're just trying to have a what if scenario. What would Earth be like if the nations got along and they explored the universe, right? That's Star Trek. But when you go and you watch 1967 Star Trek, it's not the future, it's 1967. But they threw in a couple of ideas of what ifs. And like as we're dealing with the modern acceleration of our technology with computers, with the rise of artificial intelligence, like it feels like I have trouble keeping up day to day what's happening, all of the changes. And you just know that this is going to keep on accelerating. And the term for this is the technological singularity. It feels like we are now approaching the on ramp to the technological singularity, and it feels impossible to predict what comes after what's about to happen to us over the next 10 years. Will we develop artificial intelligence? The artificial intelligence will wipe us all out? Will we develop artificial intelligence, get it under control, and have it help us transcend our human bodies and live forever and explore the universe? Will we discover that artificial intelligence is too dangerous, like as in the Dune books, and we won't let anybody develop any kind of thinking computer? It's really hard to predict what the future is going to look like until you've settled this fundamental question, like one of the biggest shifts in humanity that has ever happened. And we are now fast forwarding to that. So it's really hard for me to take any science fiction books, futuristic scientific ideas seriously when I sort of hold that against the exponential rise of technology that we're currently undergoing. None of it feels realistic to me. And so I had to take it for what it is. It's a story. It's fun. It's entertaining. Are the characters great? Is the technology help enhance the story? That's all I really care about. Jack Scioto? Okay. Jack Scioto. How large can we make Venusian cloud islands? So one of the interesting things about Venus, like overall, Venus is the worst. It sucks. Like, don't go there. It's a terrible place. But if you go to about 75 kilometers altitude in Venus, then the temperature and pressure are roughly the same as the surface of the Earth, within a few tens of degrees. But more interestingly, just breathable air is a lifting gas on Venus. And so you could go and fill a balloon with air and you can have it float in the high atmosphere of Venus. And you could walk around inside the balloon and you could breathe. And then you could have your little spacesuit on and your breathing apparatus. You could walk out to the deck and you could look down above the Venus cloud tops and enjoy the view. A few downsides. The big one being that there's still sulfuric acid in the atmosphere that's going to be gnawing away at your Venusian cloud island. So that's all sounds great, right? Well, there's like a whole bunch of downsides. So the first downside is that you have no materials. Like here on Earth, we just dig for stuff like rocks and dirt, and we grow plants, and we have the oceans, and we have breathable air, and all of these resources that we just take for granted. You're not going to have any of that stuff on Venus. You're not going to have any way that you can easily pull up material from down below. And so everything that you try to send to Venus is going to be something that you were able to send from Earth or some other place in the solar system. So it's not impossible, but it's deeply impractical. And so you're like, how large could we make Venusian cloud islands? We would have a really hard time doing such a thing. And I suspect it's going to be a long time before there's any kind of permanent presence on Venus. Hundreds of years. Like after we've really mastered living across the solar system, on the moon, on Mars, on giant orbiting space station colonies, someone's going to take a crack at living in the clouds on Venus. But, like, it's kind of like asking like how big of a houseboat could I live on in the middle of the ocean if every addition to the houseboat that I was able to make could be delivered to me by helicopter from a nearby city. Well, how many houseboats chunks can you afford? That's how many you get, right? Because it's not self-sustaining. You're not out there in the middle of the ocean building new houseboats. This isn't the raft. You 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 have to get these parts shipped in from far away. And so really it's just like how much you want to spend doing this. We could invest the entire gross domestic product of humanity to build a floating cloud island on Venus. But I don't think it's the best use of our money. There's other places that we should do this first. Hi, Torin. Okay. Mr. Lame Stranged. So I look into a telescope and I see an exoplanet light years away, as it was back then, but during that time, a civilization could have risen and sent us a signal. Yes. Yes. When we look out into space, we are looking backwards in time. And so when we see a planet that is 100 light years away, we are seeing it as it looked 100 years ago. And so when you think about other civilizations out there in the universe, they point their telescopes at planet Earth. When would they see us at different levels of technology? I mean, you could say, well, we've only been broadcasting radio signals for about 100 years, that we, so in that sphere, like maybe 10,000 stars can see us within 100 years, with 100 light years of us. And maybe for like 200 years, we've been polluting our atmosphere with coal and industrial chemicals. So maybe that's a sphere that's 200 light years away. And then beyond that, like it's really hard to tell that human beings are here because we're not really doing any dramatic changes to our environment. And so we think about if we look out into the universe, we would see the same thing. And so like one possibility is that no civilization lasts. Like we look out into the universe and they're all dead. But we should still see them at different phases. So we may see one 1,000 light years away and they're dead now, but they were thriving when the light reached us. And so that sort of argument, like because we can see all of these different slices of time across the galaxy, we would expect to see something, anything, but we don't. Negroni. Hey Fraser, I heard that the moon actually does rotate slightly as seen from Earth, showing or swaying about 2 degrees of either side as it orbits the Earth. Do you know anything about that? Yeah, this is really cool. So I'm hoping that Chad will now show a really cool animation of the moon taken from the Earth. And this isn't actually the moon. This is a simulation of the moon that's created by NASA Visualization Center. And they release one of these every year. And it's essentially the entire phases of the moon for the entire year. And so you can see the date rolling up and you can see how the moon is like wobbling back and forth and getting closer and for bigger and smaller. And also you can kind of peek around the corners of the moon. And the technical term for this is called libration. And what's happening is that the moon isn't on the same plane as the Earth. The moon is actually orbiting at a slightly different plane from the Earth. The distance to the moon is changing depending on where it is on its elliptical orbit around. And what that gets you with a combination of these different movements between the rotation of the Earth, the distance to the moon, the angle of where the moon is on its orbit, is you can kind of peek around the corners of the moon. And so you would think that we could only see 50% of the moon ever, but actually we can see a little more of it because we get these little peaks around the corner of the moon. So I love this video just to see what the moon does. And you can see how the moon just gets, like, from our perspective, it looks like the moon gets bigger and then smaller, and then bigger and then smaller. And what's really happening is that the moon is on this elliptical orbit. We don't notice this throughout the entire lunar month. And so when you get the situation where the moon is at its closest and it also happens to be a full moon, that's what they call the supermoon. And the moon is bigger and much brighter. And then when the moon is at the farthest point of its orbit and at the full moon, we call that a mini moon. And so you sort of can oscillate but once a month the moon is close, and once a month the moon is far. And sometimes when it's close, it's bright, and sometimes when it's far, it's bright. And you get this libration that allows you to see around the corners. It's such a, like, every year when this video comes out from NASA, I just will gaze slack-jawed at it, brand new each time, and I love it. Like, it's just like they've been doing this for 10 years, and I'm so grateful because it's so wonderful. Michael Nichols, why don't we see more cubes at small telescope CubeSat? Okay. Michael Nichols, why don't we see more CubeSat small telescope projects? Wouldn't even small telescopes outside the Earth atmosphere be useful? Yeah, we're at this strange time in the rise of space exploration, of space flight, of rockets, where the costs of launching rockets are coming down dramatically. So, you know, it's several $1,000s less per kilogram to launch a spacecraft into orbit. And in many cases, you can now do ride shares where you can have a satellite. There are many situations where you can do a ride share, where you can have like a small CubeSat tucked into the side of a larger mission, and it can follow on a trajectory into space. We've got this miniaturization of the technology for actually sending spacecraft into space. And a lot of like off-the-shelf software and hardware at this point will allow you to build a satellite for a fraction of the price. You can now build a satellite for a couple of $1,000s, tens of thousands of dollars. You can also launch your satellite for roughly the same amount of money. You know, I'm seeing high schools launch satellites, universities launch satellites, private companies are launching these little CubeSats. And, you know, you're seeing examples where a single Falcon will send off 60 CubeSats all in one go. So there's a lot of this. One of the biggest problems, I would say, right now is the ability to communicate your data back to Earth. And so when you build a satellite right now, if you're going to build like a small CubeSat, you got to sort of think about it. It's like these CubeSats are going around the Earth, and they need some way to transmit their data from space back to Earth. And so you've got to set up some kind of ground tracking station to follow your satellite as it comes around in low Earth orbit. And you've got just a few minutes every time it flies overhead of your tracking station to be able to transmit all of its data. And it's going to have a very powerful transmitter on the satellite. You got a very powerful receiver on the ground. Maybe you got to set up multiple receivers around the Earth. Like the infrastructure required for you to be able to transmit data to and from your satellite is a lot. And in many cases, this is the quagmire that new satellite builders get into. They're like, oh, I'd really like to build this tool that would let me observe the Earth from space. Yeah, no problem. Like all that technology, it's off the shelf, piece of cake, and you can launch it for relatively inexpensive. But how are you going to get that data back down to the ground? Like, it's a constant roadblock. And the solution is coming. Like, when you think about what's happening with these satellite networks, with Starlink, with Kuiper, you're going to have this opportunity soon where you launch a satellite. It's got a chip on board that allows it to communicate with the Starlink network or the Kuiper network or all of them. And now suddenly, what before was one of the biggest, most complicated hassles to deal with just goes away. It's just off the shelf. You install it, you pay your service to Starlink every month, and you're able to transmit data back from your satellite at high speed. But there are some CubeSat type telescopes that are in operational right now. We have one from Canada called MOST. They often call it the Hubble Space Telescope. And I actually did an interview with a scientist out of Australia who's working on a CubeSat based space telescope that's going to try to find planets orbiting around Alpha Centauri. Like, its only job is to stare at the twin stars of Alpha Centauri and try to figure out if either of them are being affected by planets. So there, I've seen lots of ideas for space telescopes for small sats, and just there's just a little more infrastructure that needs to come together, and then I think we're going to see a revolution in the kinds of missions that small groups, like, you can imagine a situation where a researcher wants to answer some question, and instead of paying time on, or you can imagine a situation where a researcher needs to answer some scientific question, make some observations, and instead of waiting in line for time on some oversubscribed telescope, they're able to build a small telescope and launch it and have it stare only at their target and gather that data. And then when the mission is over, it re-enters the Earth's atmosphere and burns up, and mission accomplished. So it's coming. It's coming. Richie Stewart, is there any evidence of another star system having an Oort cloud? No. I mean, there has been some evidence of comets in other star systems. When you think about like Oumuamua, like a comet, or Borisov, right? We got a comet from another star system. That had to come from an Oort cloud. Major Zipf. If we lived under a sun that gave out light in a different spectrum, would we have eyes that see a different spectrum? Is visible light just visible because we evolved to see it? Yeah, I think that's a great way to describe it, that we see visible light because we evolved to see visible light. Now, there's lots of good reasons, underlying like biological reasons, why the the spectra of light that we're able to perceive are the ones that we're able to perceive, that they do like good things for, like, having evolved to be able to see invisible light, to see from red to purple, allows us to see like the widest range of the kinds of things that we have to interact with on a daily basis. But we know that there are other animals on Earth that have evolved to be able to see into other spectra. Like, we know that snakes can sense infrared. We know that bumblebees can see into the infrared, which lets them see flowers better. And so we know that mantis shrimps can see many more specific wavelengths of light and perceive different colors than we do. But if we lived on a world, say a red star, and everything was red all the time, then our idea of what is the visible spectrum would probably be many different shades of red. If we went and looked around, we go like, this place all looks red, and they would say, no, there's 10 different colors, don't you see? And we would be like, nope. We would be effectively colorblind to the kinds of colors that they are able to perceive. So it's just another example that we evolved here on Earth, and we are adapted. There is no place in the universe that is better for us than Earth, and will never be. This is the best place in the universe for us. Connor C, are all the majority of hydrogen atoms from the origin of the universe? Another way hydrogen is made that has happened on a large scale since. I can't think of a large scale of hydrogen forming. I mean, there are small, like, at the end of the day, a hydrogen atom is a proton. And so you can imagine situations where protons are formed through supernova and things like that. But no, all of the hydrogen, like it's a one-way path. Hydrogen is mashed into helium, and helium is mashed into carbon, and so on. You don't go the other way. Tropical Tom Garcia, has Dr. Becky ever interviewed Fraser? We've done a couple of episodes together. So I don't think I've ever appeared on her channel, but she's appeared on my channel many times. Rocky Giuliani, why are there no efforts trying to locate the theorized black hole in the star system? Because not very many people take the idea very seriously, and even if they did, how do you perceive a black hole? You know, like, yes, a primordial mass black hole could explain the gravitational observations made about Planet 9, but it's a not widely accepted theory. It can't be disproved yet, but there's been some ideas that a black hole that matches that mass is going to be giving off some amount of Hawking radiation, and so we could theoretically detect it and see it, but you would require sort of very careful observations, and we haven't finished looking in the visible spectrum. So, like, once the Vera Rubin telescope comes online, once it discovers all of the missing objects in the solar system, once it has failed to find Planet 9, then I'm sure astronomers, and it's mapped out all of the moving objects that clearly say that there's a hidden mass out there, then astronomers will take it's a black hole theory a little more seriously. But right now they just don't. Just dye your beard black, Fraser. Why? I'm old. No way. It's like one of the cool things about being 51 is you get to have a cool gray beard. Makes you seem wise. Misnomer. There must have been a time when the cosmic background radiation was room temperature. Is it possible there were planets back then that supported life? Yeah, there was a time about 10 to 17 million years after the Big Bang when the temperature of the entire universe was room temperature. The entire universe was the habitable zone. But there probably weren't planets. But who knows? If you've got an entire universe's worth of water, and warm temperatures, or water everywhere, then who knows what kind of shenanigans life could get up to in that short period of time before everything froze out. But it sure would be an untimely end to the whole process, that life is just thriving and then the universe cools down to the point that sounds like our future. Anyway, so theoretically, sure, but there's, we have no evidence, and we may never. Kip Nielsen, when Starship breaks the record for the most epic belly flop ever, do you think it will explode dramatically or just break apart because it's empty of fuel, or will it land quite gently? Big flaps. We don't know. We don't know. I mean, like new rocket systems fail. So that's what we can expect. Like, think about how many times it took Starship to even just land safely, and they've only done it, like, they only proved they could do it once. So I anticipate many rapid, unplanned disassemblies, RUDs. Kefak, we hear a lot of theories to create artificial gravity for spaceships. Why don't we see more experiments on the topic? Seems like a critical subject to me for space travel. It's critical to you and it's critical to me. Like, I have all of these burning questions about what's it going to take for humanity to live out in space. And it really feels like the missing piece to all of the solution to all our troubles is artificial gravity, that we just got to create those gigantic rotating space stations that simulate gravity, and then all of our problems will go away. But they're big and they're expensive and they're heavy and they're technically complicated and they have risks. And just, we're not at that point in our technological scale to justify the creation of a space-based rotating, artificial gravity system. We're just not there yet. That even though there are health issues for sending astronauts to the International Space Station, that they have to exercise all the time, that they have fluid redistribution problems, especially vision problems, that the solution of a giant rotating space station just is not feasible yet. And, back to the Venus question that we talked about, like, could we build a rotating space station? Absolutely. That there have been many really interesting ideas, and not just like the big ones. Like, there's been ones that have been proposed that are very small, that the astronauts would lie inside or sit inside or stand inside, and it would be very uncomfortable, but it would at least give them some amount of artificial gravity over the course of, like, while they sleep, they're in artificial gravity, and then they get up in the morning and then they're floating around the space station again, and maybe that would do the trick. And I've even seen proposals for ones that could fit inside the fairing of a Falcon 9 rocket. And so you'd have this tiny little centrifuge that an astronaut would sit inside and they'd spin around and get this artificial gravity, and then for like 2 hours a day while they're sending emails home or listening to music or watching TV or something like that. And maybe that will solve the problem of being in space. But it's just, there was this system called Nautilus X that NASA had proposed to build a couple of years ago. And I think it was like $4 billion as a module to add to the International Space Station. And it's just, NASA has a bunch of priorities. They've got to send people to the moon. They've got to maintain other spacecraft. It's just not easy to dig up $4 billion just so you can prove that you can keep your astronauts healthy in microgravity. So, I said it, microgravity, zero gravity, microgravity in weightlessness. So, it's just, we know that humans can survive in weightlessness, and nobody is currently planning to have humans need to survive in space for longer than about a year. And so there's just no priority. At some point, when someone decides, okay, now is the time that we're going to have human beings live in space for long periods of time, then we'll see those artificial gravity stations built. Like, I know you want it. And like, I want it too, right? That how will we live in space if we don't have these artificial gravity systems? It's like a catch-22, and yet here we are. And right now the plan is maintain the International Space Station until it needs to be deorbited, send humans back to the moon and begin creating a permanent base on the moon, begin sending humans to Mars. None of that requires artificial gravity. It would be better with artificial gravity, but none of it requires it. And so that's just where the budgets are. All right. So I'm going to record all of the outros, and then we're going to keep doing the episode. So don't go anywhere. All right. If you like my answers to your questions, as well as the other things that we do at Universe Today, consider joining our Patreon club. This allows us to keep a minimum ads for everybody. Like, as you can see, there are no ads during the video. As a patron, you'll get an ad-free experience on universetoday.com for life, even if you unsubscribe. You get ad-free videos, early access to interviews, as well as other perks that are exclusive to our Patreon community. And just as an example, is that this week we recorded our first episode of our patron-only podcast. And we're calling this the shareholders meeting. And really, it's just behind the scenes Universe Today. How we choose our stories, how we work together as a team, how we plan to approach new technologies like ChatGPT and more. So if you want to sort of hear behind the scenes at Universe Today, learn how we make things, I think you'll find that really fascinating. So go to patreon.com/universe today. And thanks to Claire Bear, Addus, Paul D. Disney, John Vincent, Eric Mackey, David Robine, Paul, Werner H. Johnson, Peter G. Heltzen, Steve Gray. Join the club, patreon.com/universe today. All right, those are all the questions that we had today. Thank you, everyone, for asking them. Remember, we record this show every Monday at 5 p.m. Pacific time live. So come and join us. And don't forget to vote. If you want to stay on top of all the important space news, join my weekly email newsletter. I send it out every Friday to more than 60,000 people. I write every word, there are no ads, and it's absolutely free. Subscribe at university.com/newsletter. You can also subscribe to the Universe Today podcast. There you can find an audio version of all of our news, interviews, and Q&As, as well as exclusive content. Subscribe at university.com/podcast or search for Universe Today on Apple Podcasts, Spotify, or wherever you get your podcasts. A huge thanks to everyone who supports us on Patreon and helps us stay independent. Thanks to all the interplanetary researchers, the interstellar adventurers, and the galaxy wanderers. And a special thanks to David Giltonen, Maud So, George, Jeremy Mattern, Jordan Young, Tim Whalen, Dave Verabioff, Andrew M. Gross, and Josh Schultz, who support us at the Master of the Universe level. All your support means the universe to us. All right. Okay. Did JWST disprove the Big Bang? What is the purpose of the solar system? And how big of a star do you need to get a black hole? All this and more in this week's question show. Okay. Speeding through, Nancy. Oh, maybe Chad will just slow my text down then. August is my birthday when I turn 52. No Lagrange questions today. There were probably some Lagrange questions. Maybe we'll get the Lagrange questions now. Okay. I like Fraser doing ads right within a live show. Kills two birds with one stone and sheds evidence that the audience is still listening is the kind you want to keep. Yeah. Okay, I'm going to stop the recordings. I've totally forgot. There we go. Now we can get into the real space news. What's for dinner? So all right. So we had Chef GPT make, I gave it a constraint, which was I need you to make me a dinner made of walnuts, with walnuts. And so it came up with a focaccia with walnuts and caramelized onions. So we made that. And it was like, it ended up just being pizza. Like pizza covered with walnuts and caramelized onions and garlic and tomatoes and salt and olive oil. It was good, but it's like just like a carb dense nightmare. But yeah, but I ate before, so it's good. We need some LaForge questions. All right. How do we want to do this? Can you vote? Is there a way to make a vote in the chat? Can I make a poll? Is that not a thing? Oh, I can do a poll. Okay. All right. Here we go. All right. Fast or slow? Fast slow. Okay. Do you want me to go fast or do you want me to go slow? Do you want me to give long, luxurious answers to your questions, or do you want me to just hammer through as many questions as I can, but you might very well get one-word answers? Chef GPT walnut let you down. ChatGPT is a plagiarist for horrible American chef bloggers. Probably. What I love is I just keep pushing it out of its comfort zone. So it always wants to recommend something with stuffed peppers, and I don't have red peppers, and my wife hates red peppers, and like every time it's like, why don't you make some stuffed red peppers? I'm like, I don't want to make stuffed red peppers. Uh-oh. Can you explain the poll question? 50-50. Oh no. When do I stop? When do I let this end? Oh, this is trouble. Oh. Oh my God. Smoked salmon with honey glazed walnuts. Salmon. All right. I think we're kind of holding at 51% fast. So, all right. All right. I will try to do this as fast as humanly possible. Here we go. Bravo 1. Why won't SpaceX test out the landing and reusability of Starship? Because they're just going to test one thing at a time. And the risk is that you don't want to have your Starship blow up your launch facility. Mark Meadowland. On an interstellar highway, would previous ships' decelerating exhaust become a braking medium for later ships? Sure, but not much. Like you could imagine them putting out hydrogen and that other ships bumping into it, but it's almost nothing. Jack Cioto asked, what could we do for water at the Venus settlement? Nothing. Like maybe you could make water out of sulfuric acid, but it would require some energy to be able to do it. Donna North, could we tow our... now we're slow. If we could tow our moon to Mars orbit, would the gravitational interaction be enough to relight Mars' magnetic core? No. Mars is just too small. Like, it's just teeny tiny. Like, maybe if you crashed the moon into Mars, you would liquefy it and reignite its internal dynamo. But Mars is just so small, and so it's just gonna lose it can't hold on to a magnetic field. Kudro and friends, SpaceX is letting Starship land in our ocean. This is just for now? Yeah, just for now. Like, the plan is to land at Boca Chica with the Mechzilla to be able to catch it. So, but before they risk this hundreds of millions of dollar launch facility, they want to make sure this thing works. David Shannon, in the far-off future, what is the limit on how much activity could be done on the moon in terms of construction and mining until it affects the Earth's wall in a bad way? There's no limit. The more things you remove from the solar system, the more stable everything becomes. The most stable the Earth would be is if you removed all the other planets, all the other moons, even remove the sun. That would make Earth even more stable. Mr. and Mrs. Smith, could the International Space Station be used as a warehouse, stocked from one end to the other, and then sent to, say, the moon or Mars instead of the bottom of the ocean? I mean, theoretically, but it's a bad idea because it's just old. Like, it's so old. It's wearing down. It was never planned to go beyond low Earth orbit. It doesn't have the kind of radiation shielding you would want. And it's just like, let's say you want to go on an RV trip. Do you want to buy a RV from the 1940s that has had people continuously living in it since the 1940s, not like great maintained, like it's, like it's still functioning, but ew. So, is that what you want? No. So, like, it's an old machine, and it can't serve these additional functions. It was never planned to do this. And the amount of energy to carry it up out of the Earth's gravity well is enormous. Like, we would just have to send rocket after rocket after rocket to boost its orbit. It's time for it to come home. Senate Dabernathy, won't the whole universe be swallowed up by black holes one day? Yeah. Most of the universe will be swallowed up by black holes. There will be various chunks of rock that didn't get swallowed up by black holes, but mostly you'll have black holes, a few things that escaped black holes, and energy. Tropical Tom Garcia, in regards to the potential technological advances in space travel, was the Expanse overly optimistic or perhaps too pessimistic? All right, I'm going to end the poll. It's just like it's a dead heat, so I'm just going to go my regular speed. It's crazy. All right. So was the Expanse optimistic or perhaps too pessimistic? Overly optimistic. Yeah, the Expanse had a magical fusion drive that we don't have any idea how we can do that. So we have to be prepared that the near future exploration of the solar system is going to come with the kinds of technologies that we can comprehend today. Chemical rockets, ion engines, fusion drives, maybe, light sails, things like that. It's just different. Like, being able to hop in your spacecraft and have it give you 1G of acceleration so that you can zip around the solar system is great for telling a story. In the same way that hopping on the USS Enterprise and flying from star to star and being able to beam down to planets and is great for telling stories. But sometimes reality is a lot more complicated and more boring than stories. Francis Morin, this summer I'm going on a vacation to a dark place. According to site Dark Site Finder in Far East Canada, it will be the new moon. I will only have binoculars. What can I expect to see? I mean, you'll be able to see the Milky Way. You'll be able to see the planets that are up at the time, and you'll be able to see a lot of the summer constellations. Like, if you point towards Sagittarius, you'll be able to see some of the brighter nebulae that are in that. Probably my favorite object to look at with binoculars is the globular cluster in Hercules, M13. You'll be able to see that, no problem. There's a lot of stuff you can see. Like, I would recommend that you get a book or find a place online that will tell you. But a lot of them, if you're using binoculars, you have to know your way around the night sky, and so learn that now. Curtis Horn, I'd like to see you interview people like Eric Lerner and Paul Steinhardt. It seems there's a lot of confirmation bias going on. I don't think I'm the right person to interview them. Like, I know Brian Keating interviewed Eric Lerner, but the problem is there are, he's, back to the very beginning of the show, right? That there are people who are proposing alternative cosmologies, and they are, like, I saw Eric Lerner make comments in my interview with Brian Keating, who was talking about his interview with Eric Lerner, and it seemed very aggressive. Like it just gave me bad vibes. And so I'm not equipped to properly debunk someone who is proposing an alternative theory. That's the realm of people like Sabina Hassenfelder or Brian Keating or Ethan Siegel. Those are the people who can do a really proper job of doing an interview with someone and to push back and to because, my understanding of this controversy is that there are very established observations that that astronomers haven't there are, so Alternative cosmologies make predictions. The predictions fail to meet reality and they don't back down. But the proper response when you make a hypothesis and the hypothesis is falsified is you have to drop your hypothesis. And the second someone doesn't drop their hypothesis, my hackles go up and my skepticism. Anton wants me to put my YouTube picture back up. Fine, Anton. Here, I'm just going to put it upside down. There. How about that? Well, is that going to drive you bonkers? I had to put my room back together because we had the leak on the wall, and so as I was moving the shelves around, things fell off. Bernard Gilbert, can they salvage some of the ISS rather than letting all of that equipment just be dumped in the ocean? They could, but like, back to my houseboat example, I guess, right? Like, say you've got a houseboat, like or a trailer. You got a 1940s trailer, and that trailer is in the middle of the ocean, floating on a raft. And the question is like, could you salvage some of that trailer instead of buying a new trailer? Yes, you could. You could send a boat out to that raft and harvest pieces of that trailer, but it's going to cost you tens of thousands of dollars in diesel fuel and hire a crew and hire a boat, right? Like, at a certain point, it just isn't the most efficient use of money. Like, there's just not enough of value on the International Space Station to try and go harvest it. Tim Ellis, if the universe started at a 0 point and galaxies are all moving away, would that not make us the 0 point? So no matter where you go, it looks like the galaxies are moving away from you. Like, if you're on one side of the universe and you look, you see galaxies moving away from you, and then if you're somewhere else, you see galaxies. So there is no 0 point. Everything's moving away from everything else. Muchi Cat, I just thought of a good sponsorship top 10 video. You review the hottest stars in the galaxy while eating increasingly hotter wings. I like hot food. I like spicy food. But I don't, like, to a certain extent. Like, there's a certain point where, like, this is fun, and then this is pain. And I don't like to cross that line. Although, like, the amount of spicy food that I can handle and think it's just delicious is probably higher than most average palates because I eat a lot of spicy food, but I'm not a fan of pain. It's like, I don't get eating food that is hurting you. I don't understand. Tadayaki, hey Fraser, how lucky do you think it is that we'll be able to create a starship that can travel at a notable fraction of the speed of light in the near future? Near future, very low. But I've done a ton of episodes. Like, check out the one I did with Andrew Higgins on my channel, where we spend an hour and a half talking about practical ideas for spacecraft that can fly close to the speed of light. There's lots of ideas, but none of them are eminently practical. Yeah, so like hot ones. Like, I don't know if I'd want to. Does your nose run when you eat spicy food? No. I mean, if it's like really, like, if I accidentally eat like a bunch of horseradish when I'm having sushi or something, then yeah. But mostly no. But like hot ones, like I love, like, the concept of hot ones is wonderful. And like, if you watch it, like, seeing a person in pain brings out a more deeper version of who they are as a human. And the interviewer, I forget his name, but he's great. He does a great job of interviewing people. And if you see, he will pace himself to exactly what they're going through. So if they're having a hard time working their way through the wings, he will slow down and he will mirror their pain in a way that is quite delightful. So it's a great show, but, you know, I just, like, I just like I wouldn't want to. But I do like to eat spicy food. But I'm not like I don't have any. I don't know. Like I'm not. I don't have any notion that I'm in any way tough about that. Right. Tom, sun is very active now. Strange EMP on the way. Will planes be grounded again? Probably not. Like how many times have planes been grounded because of solar flares? Once? Never? Not enough? Like there's probably been some solar flares that we should have grounded aircraft. Louis Throttler, have you read any of Clark Ashton Smith's 1931 story, The Vaults of Yovambus? No, I haven't. Or any of his weird Mars. Is that like, oh, 1931? No, I haven't. It's so funny when you think about like how we used to think that Venus was a cloudy world. And so a lot of science fiction stories set on Venus are like that it's a jungle. Then we realize, oh, it's not a jungle. It's just a horrible sulfuric acid, carbon dioxide hellscape. Tanvir Ahmed Khan. Hey, Fraser, why is there a lack of a satellite constellation on the moon? Wouldn't they be able to do a lot more science and then send it back to Earth directly or via another satellite, or do they exist? I mean, there are some satellites at the moon right now. There is the Lunar Reconnaissance Orbiter, and there are a couple of Chinese satellites or a couple of Chinese landers on the moon. And the Chinese did have a relay satellite, Chichao, on the far side of the moon that was able to relay data from the surface of the moon. The reality is there isn't a lot of infrastructure on the moon yet, but there are plans. Like NASA is planning to build a ton of things that are going to be going to the moon. There's going to be a lot of landers, a lot of rovers. Obviously, there's going to be humans. There's going to be potentially a space telescope on the far side of the moon. And as you build up more infrastructure, there's this thing called LunaNet. And this is a collaboration between NASA and the European Space Agency to build a network of satellites, communication satellites around the moon that will help transmit data back to Earth. I think we covered this in Space Bites a couple of weeks ago that one of the big questions they have to figure out is just time on the moon. That things that are on the surface of the moon experience a different amount of time than things that are in orbit around the moon experience a different amount of time because of relativity. And so you have to, like, what is the time zone? What time zone is the moon in? So they have to work all this stuff out. So there's still a lot of collaboration and communication that has to be worked out. Negroni, wouldn't seeding life make us God? And such as God, we know how horrible life can be. We willingly create evil with it. Should we still seed life? Well, so that's the question, right? Like, and this is a philosophical question that people do have: is that on balance, is existence better than non-existence? And some philosophers say no, that existence is suffering, and that by bringing more life forms into the universe, we create more suffering. And in fact, we shouldn't exist and life shouldn't exist because life is suffering. But like, not very many people that will buy that. Like, yes, out in nature, most animals die horribly when they're eaten. That is true. But we can see situations like for most human beings, our life is not suffering and our end is not because we got eaten by a tiger. For most people, life has its ups and its downs, and we die of some health issue when we're old. So maybe we can extend that. Maybe when we get our artificial intelligence under control, we can align a universe to minimize suffering so that more life forms get to be like a dog, right? Like the life of a dog is almost perfect. They have no responsibilities. They give love, they receive love, and then they die of old age. That seems all right. Jun Liang, any evidence that supernovas create black holes, like finding a black hole? Yeah, I mean, there are examples where, I don't know if anyone's found a black hole. No. Like, unless someone knows an example. But yeah, so like when you think about the Crab Nebula, like the Crab Nebula exploded and there's a pulsar remnant in the middle of the Crab Nebula. And there's like Cassiopeia A supernova remnant and a bunch of these. And there's others where we know there's a white dwarf in the middle of them because the star puffed out its outer layers. But I don't know of an example of a nebula of a star that went supernova in our life, like in modern times, like the last 1,000 years, where the remnant is a black hole. That is a great question. Like, now that I think about this, no, I think the answer is that we don't know of any examples of this. We know examples where theoretically a black hole should have been formed, but we don't have any observational evidence for that black hole being formed because it's really hard to detect black holes. You need a companion. So we would need an example out there of two stars in a binary relationship. One star explodes as a supernova. The other star continues to orbit around that black hole. And we know that it's there and happened. Huh. God, great question. I don't know of an example of that. But it's going to be like a thing that will be found at some point. It'll be a gigantic news story. I'm sorry, I can't read the name. It's in Japanese. But didn't they already make Life in Labs? It means it's easy to go from life to no life? No. No, nobody's ever made life in the lab. Kitchies, was the solar system born or reshaped from some form of supernova? Like a supernova's cause can begin the collapse of nebulae. So as a supernova goes off, the shockwaves move through a nebula and it can cause overdensities, and those overdensities can turn into stars. So that's and we know based on the material that's in the solar system that a kilonova, probably two neutron stars, probably collided with each other about 100 million years before the solar system and helped contribute to the material in the solar system. Tom, what caused glass to form on the moon, and why was it kept secret? So glass is formed on the moon because you've got particles, like you've got asteroids, small rocks crashing to the surface of the moon. It causes intense heat and you get glass forming. And we see examples of that here on Earth all the time. Like there are forms of glass, volcanic glass, things like that are formed under intense heat. And like nobody's keeping this secret. The Chinese found some glass in one of their samples. And the thing that was kind of exciting was that they found higher amounts of water in the glass. Like when you think about it, like these little glass beads form from this impact or from volcanic flows. And then drops of water were stored inside the glass. And so the Chinese scientists cut open these little spheres of glass and they found water vapor inside of it, which is just kind of amazing. And so the original samples that came back from the moon had water in it as well, but the Chinese scientists found, I think, 3 times as much water in their samples than the ones that came back from the Apollo landings. It was not kept secret. Tom, how often does our sun go nova? When will the sun go nova again? Our sun has never gone nova, and our sun will never go nova. Brandon, out of context, when is your sci-fi book coming out? Also do an audio version. I have no plans to write a sci-fi book. My book writing days are over. Writing books is hard. Roger Ortega, by what year do project humans will conclusively determine if we are alone or not? So, I mean, like, we have no way to know if we're alone in the universe. Like, how could we know, right? Because the universe is a very big place and we can't explore every single nook and cranny. But we can do statistical analysis. Like if we build something like LUVOIR, like a 20-meter space telescope, and we examine the atmospheres of all of the planets within a few hundred light years of us with a level of detail, we could get to the point where we say, well, there is no life within 200 light years of us, no life within 1,000 light years of us. And you can then say, based on that, we can estimate that there is no life within the Milky Way, that there is a, like if we look out to 1,000 light years with a super duper telescope and we see no evidence of life at all, then we are like 95% sure that we're alone in the universe at that point. All right. So I would say 20 years. 20 years we'll build a super space telescope and it will tell us statistically whether or not we're alone in the universe. Horizon Brave. What's with all the Neptune hate and slander? Why is the best planet Neptune always skipped over missions? I have no idea. Like, I don't get it. Like, it does feel like someone has it out for Neptune. Like, Neptune insulted the world space agencies at some point, and now it's been blacklisted and no one's ever going to visit again. But actually, that's not true. I mean, the Chinese are planning to send a mission to Neptune. NASA has proposed a couple of missions. So, like, yes, please, let's go back to Neptune. All right. I'm going to wrap things up. 6:30. Yeah, this will be good. So let's wrap things up. So thank you, everyone, for hanging out tonight. Super fun. Thank you to all of the mods. Huge thanks to Nancy and the other question gatherers for pulling those questions into the database. I really appreciate that. What's next? So I interviewed Slava Turshev for the second time on Friday, and you're going to love the interview. So much fun. And then I got a bunch of really cool. Oh, right. And now I'm lining up the round 2, the phase 2 awards for the NIAC grants. So we're going to be talking about factories that print medicine in orbit for astronauts, so they can sort of custom print the molecules that they need. A comprehensive method of mitigating space debris. I forget. There's a bunch of really cool interviews coming up. So I'll be doing those over the next couple of weeks. So hopefully we will be releasing all of the old NIAC interviews, and then we'll go right into the new NIAC interviews. Like, it will always be NIAC season, I think, at this point. So, all right. Thanks, everyone. And go to bed, Anton. All right. Thanks for hanging out. We'll see you next week.